Welcome to another lecture in Ansys basic training program. We have been seeing a lot of things in the last classes, like we have been demonstrated how to create a geometry in a space climb, and we have demonstrated one-dimensional problem, two-dimensional problem, and parametric study. All those things will be studied in the last classes. For today's session, I'm going to demonstrate how to clean up the geometry. Okay. Uh, like a complex geometry. Okay, so here for this demonstration I'm taking the propeller shaft. Okay, so propeller shaft, you know, right? The blades handle having a twisted way. Okay, so sometimes you need to clean up the geometry in order to get a proper mesh. Okay, now here I'm going to take the solid structure, so I have to try to make as a three-dimensional element. I'm going to mesh as a three-dimensional mesh. Okay, previously I demonstrated how to do a one-dimensional mesh, and I demonstrated how to create a two-dimensional mesh. Okay, so for this classes, for this lecture, I'm going to demonstrate how to create a three-dimensional mesh for a three-dimensional structure. Okay, so I'm going to select a static circle open. I already created the geometry in a space climb. Okay, I'm going to import the geometry over here and right click import geometry. Okay, and I'm going to edit those geometry in space climb now. Okay, the space climb is opening now. Once the geometry has been imported, so I just imported the step file. Okay, so this is the geometry, so this is the propeller shaft. Okay, you can see this. It has two solid structure. You can see this is one, and this is the second one. Okay, so it has two structure is there, two solid structure is there. It is not a single component. Okay, and moreover, you can see this blade is a stator blade, and this is a rotating blade. You can see this blade is, it has some twisted in structure, and for this structure it doesn't have any twisted structure. Okay, and you see okay, you see this structure here. Okay, so here it's not a problem, but here you can see there is a hole is there. Okay, so you have to clean up this type of things, and you see any here also you can see this uh, some gap is there. Okay, if gap is there means there is a continuity error will come. That means you can see uh, the shaft is not in a way to uh, attach over the shaft. Okay, there is a, you can see this, the shaft is here, you can see the yellow color, right? It just passes through this stator blade, and if you zoom it over here, you can see there is no way connection between this pink color structure to the green one. So that's what has to here in this tree it shows two solids. Okay, so first thing is I have to fix this connection over here, and I'm going to fix this error also. Okay, so how to do this? Okay, so first thing is what I'm going to do is I'm going to take I'm going to take the pull option. In pull option I'm going to select this inner surface, and after that I'm going to take the up to option and up to the surfaces. Once I selected this, you can see now it is all connected now. Okay, there is no gap is here. Okay, and we have to fix this thing. Okay, so in the second blade you can see this, for this blade is fine. Okay, but there is a problem over this blade, and for this blade also fine. So the problem over the two blades, you can see this this blade and this blade has a problem. You have to remove this blade, and that means you have to uh, trim this thing. Okay, so what I'm going to do is I'm going to make it in one position. Okay, and I'm going to unselect this other one, and using the select option I'm going to select. Okay, I selected this blade alone. Okay, and right click, I'm going to delete it. Okay, now I deleted the structure. You can see this. Once I deleted the structure, the solid now it is becomes the uh, surfaces. All are surfaces. Okay, now there is a hole is there. You can see that, and you can see inner thing inside the cylinder. Lot of other components also is there. Okay, but we don't need this type of component. Okay, so I selected this thing and I am going to delete it. So why I'm deleting this means you can see that I'm going to mesh the structure into fully. Okay, I'm not if I have this type of connections over here, this bolt, all those things, means it is difficult for doing the structural three-dimensional mesh. Okay, so as of now I'm going to ignore that. So for my analysis it is not needed, so I'm going to delete these things. Okay, so you can see the inner thing, right? So I'm going to delete that thing only. So you can take it. Okay, so select this thing and I'm going to delete option. So you can delete this blade also, this blade and all. Blade means inner blade. Okay, so these things and all I'm going to delete it. Okay, so maximum I deleted these things, and there is a ring, inner ring also is there. This also I'm going to delete it, and this ring. Okay, I deleted these things. Okay, so I have this opening over here. Okay, and you can see this is that another thing. So there is a gap is there. You can see that. So I'm going to delete this wing also. So by clicking on this thing, I'm getting to what are the desired position, right? If you want to have any position, you can get into that position. Okay, so I'm going to delete over this wing. So I'm going to select here. Okay, I'm selected this thing and right click, I delete it. Okay, so I want to patch this thing. Okay, okay, so you can see this type of thing, right? I don't want this type of thing, like this type of hole. I want to patch this thing. So what I'm going to do is, like, I'm going to use the option called fill option. In fill option, I'm going to double click this edges. Once I double click means what happens, it will select this thing. Again I'm going to double click. Okay, so now this whole edges will be selected, and now after it is selected, I'm just going to click on this tick button. Okay, now it is filled. The hole is filled now. Okay, the same procedure I'm going to do for this edges. Using the same fill option, I'm going to double click this, again double click this, until all the edges has been selected. Once the all edges is selected, the required one you want to close it, that is you want to fill this gap ins, you select those edges and press the tick button. Now you can see that. So previously what happens, it is in the transparent mode, that means it is in the only surface is there. Once I fill all the holes, now the surfaces become what, three-dimensional one. Okay, and you can see this holes all we don't need it. Okay, I'm going to use the same fill option, select this inner surfaces and click tick option, so hole is vanished. The same thing I'm going to patch this hole. Okay, so why I'm patching this means, for analysis I need I'm going to do a three-dimensional full image. Okay, like I'm trying to make it as a full hex mesh. So for this, if I have this hole means, uh, for my analysis it is not needed, so I'm going to make it as full uh, hex mesh. So I'm removing those unwanted edges, unwanted holes, all those things. Okay, and in original geometry I have four wings, right? Four blades. Okay, so I deleted that two blades. I'm going to remake those blades. Okay, what I'm going to do is I'm going to mirror this blade. Okay, so there's an option called mirror. Okay, I'm going to select this mirror option. So here it is, first you have to select the mirror plane. So okay, that means we need to create a plane. Okay, so I'm going to click on the select option. First I'm going to make a mirror plane. Okay, so I'm going to make the mirror plane. So there is an option called here axis. Click on the axis and select this axis, existing axis. You can see in the tree there is one axis is created. What I'm going to do is, like, I'm going to use the circular pattern option to create the deleted wing structure, deleted this blades. Okay, I'm going to select this circular pattern now. I'm going to position the blade in this direction. Okay, I'm going to select a blade to be patterned. Okay, so now this blade is selected, and you can see this, there is a, in circular count you have to give 2. Okay, and I'm going to create this mirror in 90 degree. So I given that into 90 degree. Okay, and which axis I want to make a circular. So for this you have to select the direction. Once I select the direction, I have to select this axis I created. Okay, you can see once I selected this axis, it shows where it is going to create this mirror. Okay, so it is fine. So I'm going to click create a tick mark over here. Okay, so structure is created. The same thing, the same procedure I have to do for to creating this blade over here in this side. Okay, so I position this structure. Okay, I'm going to select the same structure blade. Now instead of 90 degree, I'm going to put 270 degree. I'm going to select this direction, select this plane. Okay, once I selected this axis, okay, see there is a blue color, right? Blue color line. So here only that blade will be created. Okay, so it is fine. So I'm going to click on the tick mark. So the blade is created. So now the structures look like good. Okay, so you can see there are two structures there. I want to combine this two structure, the two solid into single structure. So I want to use the combine option. I select the first body and I'm going to press the control button. I select the other body. Okay, once I did it means, now you can see this both has turned into one single color. So that means it is combined. Okay, So what I have to do is like it's look like fine. Okay. uh, that is I just did the topology only. Okay, so what I'm going to do is I'm going to open in the mechanical workbench over here. Okay, I'm going to try a automatic mesh for the created geometry. As of now, what I did is I just clear the geometry, like wherever the holes are present, unwanted structure is there, right? I just remove the unwanted structure. Okay, so what I'm going to do is now I'm going to demonstrate how to create a rough three-dimensional geometry for using the automatic mesh. Okay, and and I will check whether it is possible, uh, whether we can go with the automatic mesh or not. Okay, so now the geometry has been put over here. In mesh structure, right click the mesh, insert methodology, I select the whole object, I press the apply, so one body is selected here. In method automatic, what I'm going to do is I'm going to do is a hex dominant, and I'm going to use element order as linear. Okay, I'm going to give the mesh size I'm going to give as 5, and I'm going to create a geometric mesh. Okay, so this is the structure is the single structure. You can see this is some error is coming, right? You can see that uh, in mesh there is a thunder symbol is there, and in error what it shows means the mesher has failed to generate hex dominant mesh for one or more borders. Try using different mesh methods. Okay, that means I given the methodology as the hex dominant, and I want to make this all quad. So since we have the structure is this type of twisted one, so it is difficult for the software to make it all hex mesh. Okay, so this is not a sufficient one. Okay, so what I'm going to do is I'm going to clear this mesh. Okay, so what I have to do is I'm going to split the structure so that the software can able to make it it has a convenient way. If you split the structure in such a way that so it can able to do hex mesh as much as possible. Why? Because while giving the mesh itself, what will software will try to do is it will convert wherever that structure is trying to give the triangular mesh, it will convert it into triangle mesh into quad mesh. Okay, by automatic. Okay, so sometimes it is for software also it is difficult to do that conversion. Okay, in the time what we have to do is we have to make the software to do it easier. We have to split the body such a way that to it can able to create a hex mesh smoothly. Okay, for that again I'm going to open a space climb. Okay, so here I'm going to use the split body option. In split body option, I'm going to select this body, and I want to select the plane at which faces I want to split it. So I want to split it in this way. I select this body, and I select this faces. You can see face has been uh, deselected. So we splitted this two body, right? You can see I did the first one, so it is splitted in this two thing. Okay, now again I'm going to split uh, the blade separately from this shaft over here. So I've selected this body. For the plane, cutting plane, I want to select this outer surface. You can see that now each and everything, each blade has now it's come, it is splitted from the original one. Okay, now it's splitted, all the blades has been splitted. Now again what I have to do is like okay, so for this shaft I'm going to split in between the middle. Okay, so split body, select the body. For here I'm going to select this plane. Okay, now this has been splitted. Okay, so this is the splitted one. So again I'm going to make a split over here for this thing. So select this body. Select the body and select this face. Okay, so now it is filtered again. Now again I'm going to make a split over here. Okay, using the split body option, select the body and select which plane you want to cut it. Okay, so it is now it's cutted. Okay, so now splitted each and everything. This if you see this, each and everything has been splitted now. All this has separate body. Okay, this is separate one, this is separate, this is separate. So I make each one have separate entity. Okay, so now I splitted all those things. Okay, since I given splitted it has a more body, you can see this this is the overall body. If you click on this one you can see that share topology, right? You should give the share topology as share, then only you will have the connectivity over each and every structure. If you are not giving this share topology, what will happen means that there will be a continuity error in the mesh structure. Okay, so here now I'm not given any share topology over here. Okay, but actually you have to give. Okay, so for demonstration I'm going to show you, if you are not giving this share topology what will happen. Okay, so I'm going to close this structure, exit from this space client, and double click on the model. I'm going to update the model. So you can see that you have different color, right? That means in geometry as lot of things is created on their own, and here you have to apply the uh, material. Okay, for all the splitted structure I'm going to select all those things and I'm going to select structural steel itself. So I applied all the material property over for all the geometry, and then uh, I'm going to create a generate mesh. Okay, So here in the okay, I'm going to clear the mesh. What are the mesh I already created? I am going to clear all these things. Here in hex dominant, I'm going to select all the body. Select all the body, and I'm applying over here. And here I'm change to from quad try to all quad, and I'm again going to mesh it. So here you can see now you can have meshes will be all quad mesh will be created. Okay, and here in mesh size I given 5. I'm going to use now 2. I'm going to clear the generated data, and I'm going to create a generate mesh. Okay, so previously if I give the element size is 5, so we have lot of larger element over there. Okay, now I'm given the element size will be lesser. Okay, you can see that the software is trying to convert maximum doing the meshes over all the structure. Okay, you can see that mesh is done, but you can see that there is a some error message is there, and you can see that it is created the almost hex element. Okay, but you can see the continuity right over here from this structure to this structure. There is no continuity. You can see there is a node is here. Okay, but it is not continued toward the blade. Okay, so this element is not continued to the blade, so there is a error. Why? Because I am not given the shared topology. Since I am not given the shared topology, what will happen is it will create a random mesh. You can see here also there is no continuity is not here. You can see this is the element is created over here, but here there is no connection. For this node there is no connector to any node. For this it is not attached to this uh, cylindrical object. So here this type of problem will come while doing the analysis. For example, you are giving applying any load over this blade. This load is not transferred to this shaft. Okay, and you will have some error. Okay, and here also you can see this a lot of error is coming. So you can see the error. You can't it is not properly mesh. Okay, so again I'm going to give, instead of this if you give quad or tria, or if you give all tetrahedrons, and if you clear the generated data, and if you remesh this structure. Okay, now you can get the mesh is done properly, but still there is a continuity error is there. Okay, you can see there is it is not connected over any from this cylinder to this cylinder. Okay, but here since you are given the tetrahedral mesh, you can see there is a mesh is fine, there is a tick mark over here, but this is not a good mesh. Okay, so what I'm going to do is I'm going to clear again the generated data. I'm going to open the space clamp. Okay, I'm going to give the shared topology. Okay, once I given the shared topology, and I'm going to remesh the structure in the mechanical workbenches. Okay, so I'm going to select this tree in this thing. In the component you can see the share topology. I'm just going to give the share option, and I'm just close this space clamp, and I'm double click the model. I'm going to upstream the updated one. Okay, okay, now it's fine. It is updated here. What I go to this, I'm going to select all the bodies and make it as instead of tetrahedron, I'm going to make this automatic one. Okay, for mesh size I'm going to give the 2 mm one. Now I given the share topology, right? So I'm going to give the generate mesh. Okay, now you see the difference between the previous one and for this one. You can see this for here and all. Okay, for shaft and all, it creates the hex mesh, and you can see this for wing also. For blades also, it is created almost wing hex mesh. Okay, there is no triangle is not in the shaft as well as the blades, but whereas this portion, right, in this portion, now we check the continuity. You can see the continuity also is there. You can see the node is already passes. Okay, so it is intact. Now the blade is intact with this shaft. Okay, maximum the software is try to mesh quad mesh. Okay, so but this is also is good one. Why? Because it is difficult to create a quad mesh, sorry, hex mesh over this geometry. Why? Because for it is this blade is positioned in the not in the straight way, it is in the angled. For this blade also, even it is the straight one, the straight are builder also straight one, but it is not a but the blade is attached over the cylinder is not a straight way. You can see this is a some it is positioned in the angle, so that's what is very difficult to create as the hex element over here. But this itself a good mesh. So this is how you have to mesh the three-dimensional element. Okay, so we have the for the complex geometry we created the hex element and all. So the main area of concern for the propeller blade is blade only, blade and shaft. Okay, so we created all hex element in the all the wing blades and the shaft. Okay, so this is how you have to mesh the structure. Okay, and if you want to check the quality also, you can check the quality in mesh matrix, elemental quality. You can see this for hex mesh it is there, maximum it has maximum quality is there. For TED mesh also, uh, it has somewhat good quality of mesh is there for the TED mesh also. Okay, maximum predominantly hex element is more. Okay, so if you have the statistics, overall you have 29,000 nodes and 29,000 elements are present. Okay, so as of now it is a good mesh. You can see this shaft over here also, and if you see this hex mesh in the blades. Okay, it is somewhat good mesh it is there. Okay, so the only thing here we are learning is like we have to check the topology is sharing, and if there is a continuity is very important from this shaft to this. Okay, you have to make sure that continuity is there, and you have to since I splitted this each and every structure, so the software automatically uh, taken whichever the complex area, the structure is software tries to make that structure into TED mesh complex area and all, and wherever it is possible to create a hex mesh, so it will create the hex mesh. So this is a good option. Okay, so if you learned or if you get any useful information in this video, do like this video and share it with your friend. Thank you.